Okay, so in this lecture here, we're going to look at the orbit and the diameter in the metric modular space. So suppose that the pair x g sub lambda is a metric modular space, and C is a subset of X, which is non-empty, and then T is a map from C to itself. That is basically T is a self-mapping. So for any X in the set X, we define the orbit of X to be the set of elements X, T of X, T square of X, T of X to the power 3, and so forth. Note the powers here are meant in terms of composition of functions. So let us consider an example. Suppose we have the following function: T of X is equal to X. We want to know what the orbit of X is. So T square of X is by definition T of X by function composition. But T of X is equal to X. So T square of X is simply T of X, which is going to be equal to X. Now if we consider T of X to the power 3, T of X to the power 3 is going to be T of X to the power 2. But we know T of X to the power 2 is simply X. So T of X to the power 3 is also X. So in this case here, the orbit of X is a singleton. That is basically the orbit of X is just the element X. Okay, so now we're going to look at the definition of the diameter in the metric modular space. So the diameter of the orbit of X is simply given by the largest element in the set consisting of the chain distances between T of X to the power n, T of X to the power m, and T of X to the power L for all natural numbers n, m, and l. So let us give an example. Suppose that T of X is equal to X. We want to know what is the diameter of the orbit of X. So here you can see that basically because T of X is equal to X, any power of T is simply going to be X by function composition. So that means for any natural numbers n, m, and l, T of X to the power n is going to be equal to T of X to the power m is going to be equal to T of X to the power L, which is going to be equal to X. So if we consider the set of chain distances between T of X to the power n, T of X to the power m, and then T of X to the power L, that set is going to be basically consist of elements, which is basically the zero element. Because remember, the chain distance between X, Y, and Z is equal to 0 if and only if X is equal to Y is equal to Z. Now here, because the power of T to the power X is always X, then that means each element in the G distance is the same, which is X, X, X. So that tells you X has to be 0. So the soup of that set is going to be the set consisting of basically 0 elements. So the diameter of the orbit of X is going to be equal to 0.